Welcome to the Decode. This is Rev 1.16. I am Daniel Stanfill from Aurora Boardworks.
I'm Elias Malpavon with Metal Etch Services.
And I'm Sean Kincaid with K&F Electronics.
And our esteemed guest tonight or today, or whenever you're listening, is Chrys Shea, the owner at Shea Engineering Services. She has a BS in Mechanical Engineering and a MS in Manufacturing Engineering. She is the queen of SMT. Everyone knows this. She's the recipient of the prestigious SMTA Member of Technical Distinction Award and a 3-time winner of the SMTA International Best of Conference Award. And we had to just decide to stop there because we could have kept going. But Chrys, thank you so much for joining us. You've told us that you haven't joined a ton of podcasts, so we feel very grateful that you decided we were worthy of your time. I just want to say, I've seen a ton of your presentations and love how you do them. How many presentations for, say, like the SMTA do you think you've done overall?
Hundreds,
right?
Hundreds. Yeah, I started doing more publications around 2003 when I was working for Cookson Electronics and Alpha Metals. And I left in 2008 to go independent. And I've done hundreds since then. So, yeah, for the last probably 20 years, you've seen a lot of my stuff. Don't believe the stuff that's 20 years old. Don't believe anything over 5 years old, because our technology moves too fast. I'm about to retract a statement I made in 2020 about Type 5 paste, because now we need it. So I learned over the years that when you make a bold statement, you need to qualify it with, I can retract this down the road when the technology gets better. So that's what I do.
Okay, well, I recently watched, I know what slides you're talking about adjusting, because I was freshening up for this interview. So,
okay, yep.
Yeah, interesting.
I remember saying Type 4 wasn't worth it like 15 years ago. And then like 5 years ago, Type 5 wasn't worth it. And you know what? It is now. And Sean, you posted beautiful pictures.
Thank you.
Of Type 4 versus Type 5 on the micro LEDs.
Thank you.
And I don't know if you know it, but it was micro LEDs that drove the Type 5 powder manufacturing process to the level of excellence it is right now.
And now we're even beyond on 5 now, right? Plenty of Type 6 out there and a little bit of Type 7. Maybe you can just slide that statement from Type 5 to Type 7 now.
Yeah, exactly. Yeah. And you know what?
Buy
if I'm still
time.
alive in 20 years, I'll slide it again, because it'll be at like Type 11.
I had a guy the other day tell me they make 4.5 type.
Oh, yeah. That's been around for 20 years. Yeah, it's different cuts of the 4 and 5. It's a really good combo because what you're looking to get is particle packing density and that aperture. The more particles you can pack in, the better. So, you know, the old time management analogy, you put the big rocks in the jar first and then the pebbles and then the sand. That's where you get more stuff in the jar. Same thing with packing particles in an aperture. And it's not just about, I'm going to be nerdy here, sorry. It's not just about the interstitial packing inside the aperture, I'm so sorry. But your picture showed that your paste deposit is a little bit wider because you don't have as much radius on the spheres. And that's where you can really see how particle packing density makes a difference. So that's why I really like those pictures.
I was blown away. I mean, this is the same stencil thickness and cut. Nothing changed except for the paste type. And the deposit was unbelievable.
Yep.
It's because you filled the aperture more, right?
Yeah. Yes, it's like a checking account. You can't withdraw what you didn't put in. So you can't release what you don't fill.
Paste type for fill, AR for release. Like we've been talking about, Sean.
Now, the reason we have Type 4.5 was because when we needed it for the mobile market about 20 years ago, we didn't have a good enough Type 5. We had too many oxides and too many fines. So we did a cut from the Type 5 and a cut from the Type 4 and mushed them together. There is actually no type 4.5 officially in AJ standard anywhere.
Can I make my own
powder?
Can I take like half a jar of 4 and half a jar of 5 and just whip it up real good?
I'm not going on record with that.
Not your first
I'd
rodeo.
leave the powder distribution cuts to the paste manufacturers.
Okay, all right.
But, any port in a storm, you got to get stuff down the line. You got to get stuff down the line is all I'm saying.
Yeah.
I've done a lot of things that I wouldn't recommend to get stuff down the line over the course of my career.
Right.
Everyone has, right?
Mm-hmm. You make it work. That's what we do. We're engineers. We make it work.
Can you describe the actual process that they use to separate from type 3 and 4 and 5 when they're making it?
Yes, you have this giant tower, like 5 stories into the sky, with these big sisters that look like coffins or caskets. They're that big, and they have big screens in them, and they shake back and forth. And that separates the biggest particles from the next size down, and they drop into the next casket, and they shake back and forth. And that sieves them out to the next size down, and so on until you get to the bottom where you have a bunch of fines and basically dust.
Yes, 635 mesh, I think, is type 5, might be type 6, but 635 intersections in a square inch. That's some fine mesh.
Yes, it is. So that's some fine powder that's got to pop through it. And that's why now we call it type 4, type 5, type 3. Back in the olden days, we had mesh designations of what would and would not fall through. Now we have better ways of measuring powder sizes than we did back in the 70s and 80s and 90s, so it can be a little more precise.
And I remember one of them you were talking about, this individual spheres get oxidized, and that's actually beneficial during the production of the solder of the paste so that they don't agglomerate, you said, right?
Yeah.
So actually they don't start combining.
You did your homework.
And actually that's what keeps it from happening. But then the flux is necessary to help break that down and makes that paste actually run together when you're reflowing. Yeah.
Yeah, I use the analogy of M&Ms. Everybody's had M&M candies,
Yeah,
right?
it was perfect.
The crunchy candy on the outside is the oxide shell, and the good chocolate on the inside is the good solder. Now, if you don't bite the M&Ms, if you wait for them to dissolve, you realize that, it takes a while to get through that candy-coated shell. And also, if you notice, when you have the big giant M&Ms, you get a lot more chocolate once you get through the candy shell. Those little M&Ms, it's all candy shell and not much chocolate. It's the same thing with solder spheres. The bigger the sphere, we have to have that oxide shell. If it's too thick, we're not going to reflow well. But if it's too thin, the solder spheres are going to stick together and make big agglomerations that will clog your stencil or your jet. So we have to get just the right amount of oxide on there. Even if we had just the right amount of oxide on every sphere, if we look at the ratio of surface area to volume on a sphere, when we go from an average particle type 3 to type 4, we increase our oxide or our specific surface by 17%. When we go to type 5, we increase it by 33%. So just imagine, like, you've been soldering around with type 3 powders for a long time and you make a jump to 5, you've got to cut 33% more oxides. And that's why we see things like graping more frequently with smaller particles. That's why we see poorer coalescence, because a few of the smaller, finer particles don't connect on reflow. They're going to stay out on the solder mask. And that's why we have various issues in reflow with them. But
so is that
micro LEDs.
Is that one of the reasons why I have a hard time with jet printing type 5 paste on a land grid array, like those LGAs? So it just like voids really bad if I don't have the proper reflow profile.
Yeah, because when you jet paste, you have to have more flux than when you print it.
Uh-huh.
When you print paste, you're like 90% by volume, 90-10, but you're 50-50 flux and metal. When you jet it, to make that flow in the jet, you need a higher flux to metal content. And what causes your voids? Flux. flux outgassing.
Flux.
So
Yeah.
if you're running something that's 70% flux versus 50% flux, well, you can imagine you're going to get more voids. And the thing about the LGAs is there's no real good escape path. You know, bubbles want to rise up and go out the top. It's harder for them to break the surface tension on the sides.
Yeah, and even a BGA is sitting off a little bit, right, until it reflows and collapses. But the LGA is sitting a lot flatter because it doesn't have the additional sphere underneath the component to keep it elevated while it outgasses some, right?
Yeah, exactly. And when you get the BGAs, that sphere is what makes your bulk solder, and that's mostly solid. Sometimes they get voids in the spheres, but for the most part, that's solid. So the only voiding you worry about is the little, 5 or 10% that came from the paste. When you're doing LGA, you don't have that bulk solder. All you have is paste. And if you jet it, you have more flux than solder to begin with, so you're going to get more voids.
Wow.
Yeah, sad truth.
I love the M&M analogy, and just in general, appreciate your style of delivering information, right? I mean, I can think of a grilled cheese analogy, you know, and I think that's one thing that's so awesome is like you deliver things in a way that it's just like perfect. I get it now. I get it.
I appreciate that, but you have to it's like you have to have something relatable so people can understand. You probably haven't heard my tirade on squeegee blades yet. You wanna?
No time like the present.
Yeah, please, don't hold back.
When your wiper blades leave streaks on your windshield, what do?
Change them.
Change your wiper blade.
When your wiper blades leave streaks on your stencil, what do?
Change my support
running,
pins.
But nobody does.
Just do another job? What do you mean?
Yeah. Okay.
Keep going?
Now, your blades, they're not like, we call them squeegees, and we think like little rubber squeegees like stuff on our windshields. They're steel blades that need to make serious contact with the stencil. When your razor gets dull, do you keep using it?
No.
Well, see, this is interesting because Elias tells me when I get stripes on my stencil, I have to replace my stencil. He's never said anything about replacing my squeegee
He just
blades.
knows how ignorant and bullshitable you are.
Yeah, that's probably what it is. Yeah. He knows the money's that easy.
Yeah. Why do you think he's your bestie?
Yeah.
Sorry, Elias. You can cut that
You're
out.
selling me out here, Chris. You're giving up all my secrets.
You guys are fun to talk to. You're so much fun to talk to. I love all your stuff on LinkedIn.
Oh, thank you.
Thank you.
Just, we would need to be a bit higher volume for Elias to get very rich off of our account.
Well, get those
Plus,
sales
there's no
guys
way we're high enough
crack-a-lackin'.
volume for the amount of time I spend on the phone with him, making him describe every single aperture decision. There's no way he's making anything off our account.
So he must just like you as a person.
Elias tried to hire me to sneak into Daniel's place and break his jet printer, so you had to buy more stencils.
You know, I love that. Devious. That's awesome.
That's smart.
Yeah. He's no fool. He's a second generation businessman. Come on.
Yeah. He knows how it's done.
Yeah.
For stencil design, do you have like a general rule for reduction when you do reduce, how far, all that kind of stuff?
Yeah, I pretty much do. And I take for granted that I've just learned it and it's evolved over the years, and I should spend more time explaining it to people. So that's a really good question. The whole thing with stencil design is you want to try to get good gasketing. If you don't have good gasketing, you're not going to get a good print. So you need board support, you need stencils, you need squeegees that all work together. But given that boards shrink and stretch, given that pads are over-etched, we typically do a slight reduction to try to guarantee gasketing. When we get down to the 0.4 millimeter BGA range, I like to insist on mass-defined pads because they're much easier to print than metal defined. When we talk about discrete, we've done a lot of testing that shows the inverted home plate or the radius inverted home plate or the U aperture is the best way to go. I've got some design rules on where to crop the apertures for the center pads on QFNs so you get good gasketing. Because you always notice like the bridges come on the center pads, and that's because the webs are so long. If you think of them as beams, they're going to deflect more on release, and that's why you get bridges there. And you can't help it. But if you make that opening the same width as the pad, you're probably going to get bad gasketing. So you cut in 10 mils on each side of the center pad, and you know you're going to get good gasketing on the center pad, and you're not going to get as much beam web deflection, and you're going to get a cleaner print there. Now, another thing on QFNs is if you overprint the toes, it will actually, when the outside melts, it will lift the part up a little bit and allow some outgassing before the center melts and pulls it back down.
Wow.
There's 3 different studies on that. It's, the data talks. So that's kind of one of my tricks as well. And we had one the other day that Elias posted about cutting back apertures so you don't have interior corners and tines on your stencil. And that got a lot of response on social media. But
yeah, including one
really
person that called me a bad man.
I know. He's like, you're messing with my copper. Messing with your copper.
Right.
Yeah.
Or making
you
your
did that
solder
without
joints
asking
work.
him.
Yeah, I know. And you know what? I'm so restrained on social media. That's the first time I've ever said anything negative. But I saw that and I was like, terrible that manufacturer would do this. I was just like, no, terrible that you wouldn't ask.
Yeah,
I'm a huge
By the
DFM
time
girl.
by the time I saw that comment, you and Robert Gray had already jumped into my defense, and I'm like, I'm shed a tear.
he texted in the group chat.
Yeah.
He had a GIF of the. He said a GIF of the cavalry is coming, and then he sent a picture of.
That's great. That's great. That's awesome. Yeah, that was interesting, that exchange. But I'm a big DFM girl from like the get-go.
You are. I've heard you mention that a lot. I know even at the live panel you did for Mike Conrad at SMTAI, one of the things I heard you say was, about like UHDI and how the designs get more and more complex, more miniature, more densely populated all the time. But beyond making a circuit work on paper, you have to be able to actually build the thing, right? And that communication of how far the technology is and what's actually capable and what happens during the assembly process when you start bringing everything closer and closer together. Does your inspection equipment, is it capable of seeing everything that tightly packed and recognizing all the solder joints? Is your pick and place capable? Is your screening? I mean, every single part of your process has to be capable of handling this design. So that partnership needs to be way more robust. And, we need to get people working together way more than everyone just doing their own thing off in the corners. And I loved everything you had to say about that. I think that's just a big concern for the industry, the way everything's moving. And hopefully you don't mind kind of bringing up some of those points again here for us, because I loved that discussion.
Oh, not at all. Getting ready for the next level of technology has always been a passion point for me. I've always kind of been working on the 1 to 3 year what's coming next.
Mm-hmm.
And for 35 years that I've been doing this, somebody comes up with a better board fab, somebody comes up with a better package. Nobody tells us till we see it on the BOM, on the NPI run, and go, little time with it. Sean, you're laughing because you played that game. Daddy, you're laughing because you played that game. Yeah, so I'm like, okay.
Yeah.
It's only been 35 years of whiplash from being at the end of the whip when all the stuff comes together. Hey, why don't we learn a lesson from our experience and get on board up front? It's coming. We're not going to stop it. And we might as well get ready, or we're just going to get caught and backed in a corner and have lousy yields and struggle as an industry to get the stuff moving. We know it's coming.
Yeah.
Why don't we just get ready for it? And so we came up with that Ultra HDI board where, oh my God, I could not think of some more brutal things to put in that design. I'm really proud of the brutality.
It's a nasty booger.
That I put in it.
Made it as challenging as you possibly could, right? Oh.
Yeah. One of the people who's printing it right now called it a cluster cluck. So
that's safe. We don't even have to edit that one.
Yeah, he said the safe text. But well, it's meant to be. It's supposed to be.
That's great.
And so what I did with that was I did the outer layers of what I'm calling, unfortunately, the known unknowns. Some of the things we can anticipate with densification. There's going to be a lot of unknown unknowns too, but at least, there's 6 or 10 things we can't anticipate. So let's get those down there. And what I'm working on now is combining some of the Ultra HDI fab inner layers with the outer layers. Because if you think about it, it's going to speed our technology transfer. It's going to speed our time to market if we work together on it. And historically, we've tested fab and one certain type of test, and we've tested solder joints and assemblies and another type of test. And we qualify them separately, and then they come to our assembly line, and we go, so hey, here's a concept. Why don't we test them together? Why don't we impose the real system constraints on the system and test them together? Because when we talk about things in the board that are reliant on thermal expansion, and then we solder down a bunch of ceramic capacitors that aren't going to allow the expansion, then what's going to happen? Well, let's not find out with field failures. Let's kind of anticipate it up front. And Sean, what might be good for fab might not be good for assembly.
100%.
Let's figure that out now and catch it before it catches us. That's kind of how I feel on that.
That kind of reminds me. The other day, I was talking to these guys, and it seemed like a couple weeks ago, everybody's talking about printing in air with printing over air. I forget what people call it, with the silk screen, raising the stencil height basically. Printing. So I had an idea. I had an idea on the PCB.
I hate silk screen.
Why don't we just remove where you're going to place the silk screen, right? Remove that from the mask and then place your silk screen or white mask over that. And then there you'll have an even layer count, right? Like, so when you expose the mask, you have a depression now where your silk is going to go, right? And then not because it's not exposed, and then you lay your silk screen down, and then now you have that layer and they're both the same level. Why don't we do that?
And now the silk is flush.
Yeah.
I like that. But what if we're doing like LPI mask? We'll be able to.
That's fine. Yeah, I mean, I don't have a problem with any of it.
Seriously. No. In 1999, in the last decade, guys, I don't know if you were in college or high school or diapers, but we got rid of silkscreen in the late 90s on cell phones because we didn't have room for it.
Sure.
And we had, factory logics type of software, and our inspectors could still, key in where the defects were. But we had a whole lot less because we didn't have the silkscreen shimming up the stencil. Now, we needed silkscreen on our hand stuffing boards. Back in the olden days, we needed the polarity marks and the right size box around it. Can you tell me any good reason why you need a silkscreen box around a QFN? Is that going to help your placer place it? No, your placer no centroids. Doesn't care about that.
No, in fact,
why do we have
that outline isn't going to be made with the same type of tolerances and, perfection that the pad's meant to be to the XY coordinates. So if you're trying to align to that silkscreen outline, you're just asking for trouble. Like, that's not what you need to align to.
No.
And
your placer's no centroids and your CAD no centroids. And there's no little old ladies stuffing boards anymore. So I get it. If you have jumpers or connectors or field service things, you might need to put some nomenclature on the board. And I get when you have a diode or a BGA or QFN, you need the polarity mark. But why can't you put that in copper and relieve the mask around it? Why do you have to make a big lump of white goo? Really, think about it.
I don't like that as a PCB fab guy because that makes it harder to etch. You get into a really small dot. But I mean, it's doable. But in PCB fab, so some customers didn't want to pay for silkscreen, so they would make us do the copper, but they would put like lettering, right, and it'd be super thin, like six thou, right, traces.
Well,
yeah. And then etching that was a nightmare because sometimes you make a beautiful circuit board and then you etch that down, and if your etching tank rises too hot during it, especially during like a 3-ounce etch, it goes away sometimes, and then you just wasted a panel because they didn't want to spend money on the silkscreen. So I usually used to offer silkscreen for free. I was
for
like,
free?
can we please just, yeah.
But now that you assemble the boards, what's your position on that?
I'm leaning towards like you guys now, where especially when I'm getting into these smaller and smaller packages, like a SOD 523 even, and you got a box around it, and I'm already printing on Hazel, on this, and it's like this is like everything is against me. Can we please just add this factor into it too?
Yeah,
so, but I don't
why
know.
do you need a box around a resistor and SOT? What's the point? You know where these are coming from, in my opinion, is we used to have master component libraries in our CAD systems, and we would say to the librarian, take the silk screen off that pad stack, right? But now you get so many pad stacks off the internet, and you get so many pad stacks that have been put out there by component company marketing firms that just don't know, and people just take these, and it's great now. You don't have to do your own pad stack. You can just download it from the internet or from the component company, but that doesn't mean it's the best pad stack.
Right.
No.
Chrys, you mentioned that you worked previously at Cookson. What were you in Alpha? Were you involved in stencil manufacturing? I know that was one of the things that they did back then. What was your role there?
I was working in the development lab for pastes and stencils. So we would do a lot of testing of different solder pastes, a lot of development testing, a lot of final testing, a lot of fitness for use testing, a lot of scale-up testing. And we did a lot of stencil testing as well. That stencil operation was headquartered up in Johnson City, New York, or Vestal, New York. And there was a chemist there, because remember the days when we chemically etched stencils?
Sure.
Like way before the laser came out. Oh, you don't, but I do. Anyway, the guy was a statistical wizard, and he was the one who, when we plotted different things, discovered the area ratio rule back in like late 90s, early 2000s. Because I went into that lab in 2003, and we did more work on it and wrote more studies on it. But yeah, Ron, oh God help me, as soon as we get off the podcast, I'll remember his last name, but he was just like this chemist, statistical, crazy wizard smart guy who would plug in data in Excel and run different models and see whether it was a quadratic equation or a slope and intercept or exponential, and write these equations for it. I was like, dude's got it going on.
Did you guys want to keep that secret in house, or because it's like everybody talks about it now? Wow.
Oh yeah, we published it. And also part of the I can still see the original graph in my mind that shows transfer efficiency goes down as area ratio goes down, and variation goes up as area ratio goes down, and the curves just kind of went in opposite directions. It was really cool.
Wow.
So I started building off of that in 2003 or 2004. And we just went from there, and that's when you saw all those different studies on printing and apertures and lead-free and what are we going to do next. So that was a fun learning period of my life, 5 years in that lab. Learned a lot about paste printing, stencils. I ended up working for datum alloys, because they're developing so many new metals that we would do a lot of experiments and see what metal is best, what cut parameters are best, does tension work, doesn't it work, how does laser cut compare to electroformed, let's test these new coatings. I did a lot of that work with Ray Whittier at Vicor, now he's at BAE, but that was a lot of fun.
There's a little bit of a Cookson datum connection there, right?
I think when Cookson shut down the operation there and were laying off people, Datum saw the opportunity to scoop up the talent, and they opened a shop up the street where they do their pre-mounts and that kind of stuff. And they brought some of the stencil guys with them, and that's where the guys
Sure.
who brought me into Datum.
So, Chrys, I've had I just had the opportunity, process engineer by me that's been doing this stuff for 36 years is basically retiring from his main job, and big family friend of mine for a long time, and he is just helping me out at the shop, coming in and just giving me advice and taking me to the next level. And I was running that micro LED job, and this one's actually a double-sided assembly, and we ran the first side with the Type 5, but this was like connectors, and I think the smalls was like a 0402, if I'm right on that, Elias. I don't. He made the stencil. It wasn't crazy small. Yeah, so like the 042. I mean, the connector had a pretty tight pitch, but it wasn't. It's just a connector. So, you know what was weird though? Was we ran it through my standard lead profile, which is usually pretty solid. And I don't know if it was because there was a lot of copper on this, or we're using a FR4 unclad carrier on there, but a lot of the paste didn't flow correctly. You could just see it just wasn't fully wetting all the way out. And so he just, he's a wizard. And thankfully he used the BTU oven that I've got for years. So he comes over there, but he changed one thing, and he said, I don't know if this is true or not, but he says, nobody ever talks about airflow. Nobody talks about it. He goes, watch this. And all he did was change my airflow. Now, I got a nitrogen one, so I don't know what the actual percentage of the fan would go down. But for example, it was like I had 1.2 in zone 1, 1.2 in zone 2, 1.2 in zone 3, and then my cooling was 0.8. He changed like the first two to like 0.7s, and then the last one was a 1.1 during like the final heat, and then the cooling he moved up to a 1.2. And just that little change, because he said he noticed that the flux was like gone too soon. That's what he was looking at when he came out. He said the flux is drying up way too quickly, so let's lower the air fan over this so that way it's not whipping it all around and drying it out prior to
You're lucky to have that guy around.
It's and then so it ran an unbelievable. I mean, we're talking like just this fillet, just beautiful over all of these pads and these pins, and the connector was just. It looked like a master class just happened, like a world class solderer just soldered this versus the one I had prior. How come nobody talks about airflow as much?
Nobody really talks about process as much anymore, do they? One of the things we know. When we increase the airflow, we can increase the convection rate and we improve our heat transfer, but we also dry all the flux off the outside of the part, and that's what gives us, you didn't quite get to the stage of graping, but you didn't have enough flux. And there's two things that can happen. You can burn out your flux by overactivating it thermally, or you can dry out your flux by blowing too much air past it. And it sounds like you were doing the latter, not the former. Yeah, nobody talks about that. Everybody says, run the fan as high as you can, and if it blows parts around, take it down a little bit. Right? But when you see the graping, the poor flow, you got to take it down a little bit as well. So you bring up a really good subtlety in the process.
I didn't even notice that those were even settings I could change on there. I just thought it was like a default. That's just what, 1.2, 1.2, 1.2, and 0.08, right? Like that.
Oh, no.
I don't even know.
Well, sometimes we call it fan speeds. Sometimes we call it static pressure. And sometimes we call it like whatever we're feeding the motor. So there's no common nomenclature across the different ovens.
Depending on the manufacturer of the oven, or
Yes.
But it's not on the
Yes, 'cause
data
some of
sheets either, right, of the paste.
Nope.
I've never seen it once in my solder star profiler, none of that stuff. You know what I'm saying? I've never seen anything where it says, hey, you can run the same exact profile, just turn your pressure down to this, or turn your
yeah, I
fan
don't think
speed
my
down.
kick profiler says anything about the air either. Actually,
Right?
it doesn't
No.
even factor it.
Convection is so hard to quantify. If you think about convection rates and the topography of the boards and where the air is going to blow, and just think about skyscrapers in a windy city and the wind tunnels that get created.
There you go. Describing it perfectly.
There we go again. Yep, I love my analogies.
Yeah, I was picturing big fans when you said that too. I'm like, oh wow, yeah, it's doing this, right?
Yeah, exactly. So, it's something we're not very certain about. So not going to go talking about it a lot. And now, if I were the paste company, I would not put anything about fan speed on my data sheet, because if somebody doesn't like that, they may never try my product.
Mm-hmm.
People look at the data sheets before they bring in the products. Nobody wants
Is that
to
why
lose
they
an
say?
opportunity.
Is that why they say a suggested speed of 1 millimeter a second to 5,000 millimeters a second?
Exactly. You can drive the truck through it. They're not going to get eliminated on paper.
Right.
They're going to get their product in for you to try. Exactly. And that's why the reflow profiles, because every paste has a nice sweet spot. And some of them are better at quick ramps and 3.5 minutes to peak. And some of them are better at long soaks, 5.5 minutes to peak. And there's always a happy medium. Nobody's going to tell you that, because if they say this looks great on a 3.5 minute ramp to peak, you're going to say, oh, God, well, I got a 5 minute time to peak because I got a soak zone, so I'm not going to try the paste. Nobody wants that. They want to bring the product in and have you try it. So
That's good
the data
insight.
sheets are particularly nebulous for a good reason.
Yeah, I looked it up for one time on one of the jobs, and exactly like Daniel said, it was the widest range I've ever seen. I was like, this is not helpful at all.
Oh, yeah, I can run this paste at 1 to 8 inches per second on my printer.
Right.
Is it really going to perform the same at 1 and 8? No, it's probably sweet in the 2 to 4 range. Yeah.
Right.
Yeah.
Right.
Especially depending on, squeegee blade pressure and a number of things, right?
Temperature of paste.
Well, think about squeegee, bring up a great point. Squeegee blade pressure. We say, oh, you run it around, and I'm old in imperial units, about 1.25 pounds per inch of squeegee length, right? And our data sheets say you can run it anywhere between 1 and 1.5. That's a lot, because when we say 1 pound per inch, we're not saying 1 pound per square inch. We're not saying 1 psi. We're talking about 1 pound per linear inch. And that squeegee blade is 7.5 thou wide. So let's just say it's got 10,000 contact by 1 inch. When you put that 1 pound per inch and you do the math for pounds per square inch on a blade that's 10 thou wide, you're looking at 100 psi. Now, the blade doesn't come straight down. It's usually somewhere between 45 and 60. Do the vector math, you're still looking at somewhere around 50 psi. That squeegee is driving across that stencil at. That's a lot of pressure. What do you inflate your tires to? 35?
40. 40.
And what happens when they blow?
You better have good gasketing if you're doing that.
Well, we just don't think about it, but that's putting a ton of pressure on there. And that brings me to one of my other soapboxes, which is board support. If you don't support the board, you're not going to get a good print, because when you're putting that much pressure on it, it's going to deflect. And the stuff's going to pop back before the board does. And that's why you get a mushy print or a really tall print when you're not getting good gasketing from bad board support. So when you think about it all in that context, it kind of makes sense.
That was actually like, were you talking about your wiper blades? So I had a dinged in the corner blade the other day, and actually I at least post where one of his customers dropped it on a stencil and it ripped right through there. I was actually gonna test
I
it
saw
out, but I don't have another 325 millimeters, so I'm like, I want to do this really bad, but we're gonna just save the frame. But if I had another one, buddy, I would, because I was gonna bet him $1,000 that it wouldn't go through. But anyways, I digress. So I'm pasting across and I'm noticing it in the left side. I'm getting that streaks, right? And it's really affecting me because I'm taking it out after it's been kneaded, and I need to wipe off the top now because my fiducials are now covered because of that streak. That's where it is in the lower left corner, right? And so he came over, the process engineer, and he was looking at it, and the way my board support was, right? Like, so I had them kind of staggered around, right? And just kind of randomly. I just basically try to get the edges, right? But he was saying, no, you want your Z height to be flat, right? So your Z height's flat, space them out evenly across. So if it's a 1 inch from rail, make your other one 1 inch from rail. And then if you have another one, put 1 inch in between the two, right? Have it out evenly so it all rises up together at the same time, right? And then it all comes down.
Yeah.
And once we did all that, it fixed everything except for that on the back squeegee printing from back to front, where that dent was on there. Because then he said, all right, we got to take this off and look at it to see how is it dented. And then it sure was. But just that little advice of like making your board supports evenly spaced.
Do you not program where to put the board supports, Sean?
What do you mean by that? I have the magnetic pins.
Yeah, me too, but well, I don't know if they're magnetic, but
do you place them by hand or do you machine place them?
Place them by hand. Yeah, I got to place them by hand.
Place them by hand, but laser guide. Are yours laser guided or no? Is that the difference?
What?
Okay. I can tell by his face like now.
We have the same
magnetic.
We have the same printer, which is why I thought he might have that. But because when I'm doing that, I use the Gerber, find the empty spot on the board, and program, to space it out as evenly as I can, distribute it across the board. But it's not gonna, when you're doing the second side of the assembly, you won't be having any of your board supports pushing up against any of the components. So and then a laser comes over and points out right where to put it. You put the magnets down right where the laser points it out and stuff like. And that's the cheap method compared to they also have the automatic, which is we should have done, which should just never even have to worry about it. It just forever, any board, any style, whatever, it just always has the right support.
I actually got a free sample of those pins coming in this week. I'm super excited to try. They give me a 1 month trial too before, and then they're gonna do 4-month payment plan. I'm like, man, yes, sign me up for this thing. So yeah, it's gonna be those pins that come up automatically or whatever. But I want this laser too.
Oh, like the gridlock? You're talking about like the
something
gridlock
like that.
pneumatic pins?
These guys changed names like 4 times. A quick tool or something.
I think the patents ran out and a lot of people make them now. They're good. They're better than manually placed pins, right? Definitely better than manually placed pins. If you are manually placing pins, you should have a template so the operators place them in the same place all the time. Just a simple little template that you cut out of a piece of plastic. But when you have the gridlocks or whatever we're calling the pneumatic pin supports, you have to be careful about your setup and tear down. Remember the thing I posted the other day about you do the squeegees? You do the stencil, you take the paste off the squeegees, then you pull the stencil, then you pull the squeegees. But if you don't take the paste off, it's going to drip down your tooling nest. Nothing seizes up those pneumatic pins better than dried solder paste.
Oh, wow.
Yep.
Yeah, because I'm lazy sometimes.
Gotta be careful
guilty
about not dripping paste in there. And every day before they set up, they should pull it out and tip it upside down. And if the pins don't come out freely, they need to clean it before they run it. Because once those pins get stuck in a down position, they're not going to get support. And if they get stuck in an up position on the next board that you run, they could crush a component, after a changeover. So they're really, really good because they're quick, they're cheap, they stay in the machine. Not cheap, you know what I mean.
Does it change your minimum board width or no?
They're
Is
only
it
about this
narrow
wide.
enough? Okay.
Yeah.
So,
Usually you'll stack 3 or 4 or 5 in, depending on the board width. Now, one of the things I like
okay.
to do is stagger them in X so that you've got a more offset matrix instead of a straight one, so you won't have weak streaks as you travel across. Am I making any sense?
Why would the X benefit?
Well, let's just say they're on 1-inch centers. If you have all those pins lined up in the Y direction, you're going to have unsupported.
You'll create peaks and valleys, small, but
Yep.
peaks and valleys, right?
But now if you take them and offset them by half the pitch, you're going to eliminate some of those peaks and valleys.
Wow.
Because you're going to have better support.
You guys want to see me kick the hornet's nest?
Yes.
Yes.
Over the board clamp.
Oh, you had to go there. You had to go there. You had to go there. What do I dislike more than silkscreen? Beck, I have a special name for them. Over the top clamps. Because they really go over the top when it screws your printing up. If you got breakaways on your board, your over the top clamps aren't going to hurt you. If you don't have breakaways, you're shimming that stencil up even higher than a silk screen would. If you are using those on boards without breakaways and you do your defect map, you're going to find more opens and more shorts on the BGAs that are up against those clamps. So what do we do when we have over the top clamps and no breakaways? We half etch the bottom of the stencil to give clearance for them. And then we really just disempower the whole negative effects that they're putting on us. So we like to slay that dragon.
Yeah, I thought that was a genius way to handle it and an easy one, really. So I don't know. You guys clamp go over the board? I believe they do. Maybe we'll have to
custom carriers if I don't have rails or anything like that. So I don't ever go straight up against the board. That's crazy talk.
Same.
I'm with you, Chris.
It's crazy talk.
Yeah. And then throw a BGA near that edge, you're nuts. And that's a no bid if you want me
Crazy
to do
count.
that. Yeah.
Yep.
No,
you know, a lot of shops don't really collect quality data, so they can't do that analysis. And then say, gee, if I map out where I'm doing all my rework, it seems like it's right up against the rail. But if you have SPI and you mine the data, it jumps right out at you.
Yeah.
Instantly.
Sure.
Because you have so much variation up against the rails. And that's one of the reasons I like SPI so much.
If you had to invest into one piece of equipment, SPI, AOI, or X-ray, which one would you choose? You only get to get one of them, though.
SPI all day long. I've been saying this for
Chris,
years. If you only have... What? Go ahead.
Can you just start this over again and start it with Gary Bales and then say everything you're going to say about SPI? That'd be really helpful.
Oh, okay. Well, what about like Justin Orbach? Should I mention him too?
Well, I don't work for him. I just need my boss to hear this, and then I'll be good.
For years, I've been saying if your budget only has one piece of automated inspection equipment in for next year, get the SPI. That's the most bang for your buck. That's where you stop defects at the pass. If you get an AOI and find you have a lot of soldering defects post reflow, yeah, great. You already made all the defects.
Yep.
If you have an SPI, you're going to stop it in its tracks.
Yeah. I bought an AOI first, and then I got my SPI, and because you buy this thing and you're like, there's no return on investment. This thing is going to slow down my production, and it's going to, it's just going to cost me money. It's not, but then you start running it and you realize, oh, that's why that Bluetooth is chip bridging, right? Oh, that's why that product is coming back. And then all of a sudden, the RMAs went from, it wasn't high, it was like 3%, but now I'm 1% or less.
Yeah. Yeah, because the solder paste print is the foundation of the whole process. You don't build a house on sand, right?
Right.
If you don't get the print right, you can get the print right and still have rework at the end of the line. But if you don't get the print right, you're pretty much guaranteed rework at the end of the line. So get the print right.
Yeah, it's a game changer. It really is. It
Yeah,
really is.
yeah. We had kind of lame laser rangefinder type SPI up until the early 2000s, and the GRNR was like 20%. So they really weren't worth the data they would produce because there's so much variation in the data. Then it was the early 2000s when Ko-Young came out with the Moray interferometry, and that was a game changer. That was a huge game changer. That's where we now get GRNRs well below 10%, and we can look at it from different angles. And now there's a whole bunch of different SPI types out there.
How accurately they can measure height just because of the line shifts a little bit, with the light going across it. That's crazy.
I know, and I got another analogy for you guys. Anybody have vertical blinds in their house?
I've had.
Yeah.
Have you had them? And when the sun comes through the window and the vertical blinds put the stripes across your table, you see them jog when it goes over a dish or a plate or a cup or a book. You can see the jog in those lines. That's how it all works. In fact, this is a weird story, but we're renovating our house that's got cathedral ceilings, and there's an addition. So you know how the ceiling height is off by like 2 inches when you put an addition on? We were going to put shiplap planks up there. And then I was like, oh no, because it's going to be an optical illusion. It's going to look like they don't line up where the roof lines meet. It's going to be like a bad moire pattern, and it's going to drive me crazy. So we're skim coating. So yeah, sometimes you take work home a little too much.
Yeah, sure. Quite literally.
Yeah, but I was like, I can't live with the bad moire.
You mentioned earlier that you always like to focus on what's coming next, and I believe that was exactly how Mike Conrad described HandPack to me, that's where you go to learn about the technology that's coming down the pipeline and new processes or equipment or methodology, just all kinds of crazy, cool, exploratory technology. Are you going to HandPack, and would you kind of agree with that assessment? And where's the value in going, would you say?
I'm going to HandPack this year. It's a really fun event, and in contrast to something like SMTAI, to Mike's point, it's stuff that's out there. It's stuff that makes you think, and it's stuff that makes you want to synthesize new ideas and go, that's coming my way. That's coming my way. And you listen to all this really cool new technology, and then you go have a couple of Mai Tais, and you wake up in the morning with a new invention in your head.
Love it.
So yeah, it's pretty cool. I went probably 10 years ago, and I'm going again this year. So it'll be a fun trip.
Very cool.
It'll be a real fun trip. We booked it right around our 35th anniversary. Because we're like, let's go to Hawaii next year. And then it's right after my 60th birthday, so we'll have some celebrating to do in Hawaii.
You mentioned on BGAs that for sure you prefer printing onto mass-defined pads. This has kind of been a reoccurring topic, mass-defined, non-mass-defined. It took a full probably 3.5 episodes for Sean to even get on the same page with us with what we were talking about. So do you have a preference beyond BGAs, whether you prefer to be copper-defined or mass-defined when you're printing?
You're always going to print better on mass-defined pads. It naturally provides the gasket you're looking for.
It just seats to the mask.
Yeah, it's a beautiful thing. The smaller the feature, the more likely it is to get over-etched. So if I spec a 10 mil pad, I may get an 8 mil pad. How am I going to gasket my 9 mil stencil on my 8 mil pad? But if I'm mass defining a 10 mil pad, I'm growing at 16. And I'm bringing in the mask on it. So even if I do a little over-etch on the 16, which is less likely, I'm still going to have a good gasket. Now, the argument on mass versus metal in BGAs dates back to when we had really big plastic BGAs, and we still do. If we did a mass-defined pad, the corner that the pad made in the joint was considered a stress concentrator, and it could be the origin of a crack. Also, on big BGAs, because we see so much expansion, we like the wraparound on the metal-defined pad, the little wraparound where it goes around the pad. That makes us feel good. It makes us feel like we're going to get a better shear strength. So that's an excellent argument to have metal-defined pads on the larger BGAs. When we get down to a 0.4 BGA and our nominal pad is 8 thou, that's going to lift right off the board under stress. So we're better off mass defining it. It gives it a little more stick to the board, a little more adhesion.
It keeps it down.
Yep. And are we going to care about a stress concentrator? A joint that's only 8 mils wide, if you shear it, it's going to crack anyway, which is why so often we put underfill under those anyway. So it just makes more sense when you get smaller to go with mass-defined pads. It's better for printing, assembly, and reliability. And it's probably better for fab, too, because you don't get rejects on over it.
It took me forever to understand what they were talking about, because in the PCB fab world, Daniel's showing me a picture of a board with solder mask on it and saying it's non-solder mask defined. I'm like, it's got solder mask on it, dude. What are you talking about? Like,
I would love to be part of that conversation, just to fly on the wall and be like, who's on first, what's on second?
That's what it was. Absolutely.
I love it.
And I'm like, what are you talking about? It's like there's an
over
there.
and over.
Either you want mask or you don't. What do you want? Like, because when you're exposing, like especially in film, there's either a black, right, where it's not going to shine through, or a clear where it's going to leave on the board. So what do you want? Like, I could care less but what I'm looking at is exposed mask. So there's mask there, right? I just hate the term non-solder mask defined, just because it kind of implies to the, at least in just, if you had just PCB fab knowledge, that there's no solder mask there. And I'm looking at solder, so it kept like, I don't, there's mask, there's mask. There's
the SMD and SMD doesn't sit well with me either. That's why I usually call the pads, the NSMD pads, metal defined or copper defined. Yep, mass defined or copper defined.
Thank you.
And that, more sensible nomenclature.
That doesn't make you right, Sean, just so you know.
That's what he heard.
Yeah.
I know. He's like, oh, thanks. You wouldn't have understood them for 4 episodes either. Yeah, that's it.
Well, you can't tell me I need to be more educated when you don't give me the whole story.
I've got one thing that I just have to get your hot take on. So, I don't know, it was about a month ago that I saw the Murata 006 003 passive. My goodness gracious.
You go for the jugular, don't you?
Is it already ruining your life? What's that look of pain and agony about?
I gotta respin the Ultra HDI board now. We have a more smaller component.
That's another opportunity,
Yeah. You have to retract.
It's going to be crazy, though. It's going to be crazy.
Wild, right?
Yeah, but you know what? It's not going to stop there. It's just going to continue.
What?
And that's why we have a surface mount bug. We have a sickness. Once you get into surface mount process engineering, you can't get out of it, because as soon as you figure out one package, the next smaller one's coming, and you work hard and you figure that one out, and the next smaller one's coming, and that's we get pulled in, and we just
just
can't
when I
pull
thought
out.
I was out.
Yes,
right.
Like I thought I was out into the street twice, and here I am again.
Yeah.
You just can't help it. You get pulled back in. It's just too much fun.
You really think it's going to get smaller?
It's always going to get smaller.
That's
more.
Has it ever stopped getting smaller?
That's true, because I mean, even like 01005, looking at that, it's like it'll never get smaller than this, and boom, 008, 004. Well, surely that's the limit, right? So, yeah, I guess not. Here we go again.
Yep.
At some
and then there'll be more and more and more.
It's crazy.
The tooling to pick it up and place it accurately,
right.
Wow.
The nozzle. What are you hollowing out? An acupuncture
Yeah.
needle? You know?
Yeah. Right.
Yeah.
Yeah, it's nuts, but that's what keeps us coming back.
Even placing
That's
those
what keeps
parts
us
in the
coming
tape,
back.
that's crazy to me how they do that. It's so tiny.
Oh, yeah.
So tiny.
I had some show and tell with me this week, and I had some tape with 08 04s, and I don't call them 008 004s because they're more like 08 004s. You go when you see them on the bomb. And even the tape pockets, you can't see them even in the tape pockets. You have to
Wow.
put your glasses on, put your phone on, zoom in, like, oh yeah, there's something in there.
Wow.
Yeah.
I've been trying to get my hands on the data sheet for the 006, 003 because I want to try to cut the apertures right, but I haven't seen it yet. I'm on the lookout. If you get it before I do, send it.
All right, because you know what? I'm like, your beam is 0.5 mil wide, right?
It's like a little bit more, 20 microns.
Oh God! All right, so you don't have to worry about rounding the aperture corners because you're only going to get
they're
one
going to be
pass
rounded
of
whether you
laser
like
anyway.
it or not.
You just have to turn the beam on, and it's made the aperture.
There you go. That's going to be really interesting, seeing how those cut. You know?
Yeah.
Maybe Datum's going to have to come up with a new foil.
Yeah.
Dina, time to come up with a new foil if you're watching.
Ultra fine grained.
Yes. You can't have ultra because I have ultra on the Ultra HDI board. You have to have like super fine grain or something like that. Actually, here's one of my nerd jokes. We have the SMT test vehicle. We call it the MTV, right? Miniaturization test vehicle. And then we came out with this new Ultra HDI one. So we're calling it the Micro or the Mu MTV. And I'm like, because it is smaller, so the Micro, the Mu makes sense. But if we're going with Greek letters, should I call it the new MTV? Get it? Sean's shaking his head. Text him the Greek alphabet. He'll figure it out. Or he's just disgusted with me. Okay.
No, way over my head.
I thought for sure you were a frat boy, Sean. You don't know the Greek alphabet?
Yeah.
No, buddy. Trust me. 8 years
It's
of
like
community
I hardly know the
college,
English alphabet.
No.
Well,
no, I was
when
running
we spin
these
the board,
streets.
we'll call the next revenue.
Well, Chris, you've been so gracious with your time to join us and have this blast with us. I can't thank you enough for joining us. This has really been super fun for all of us, I know. I'll let Elias and Sean thank you themselves, but I just really don't even know what else to say. We joked around with Mike Conrad that there's no point of even continuing the podcast because you were like you're the peak. You were the guest we all wanted as soon as we started to do this. So I don't really know where we go from here, but it was a fun ride while it lasted, and thank you for being a part of it.
I've had a blast with you guys. I think I spend a lot more time with you than you realize. I don't jump in a whole lot on LinkedIn, but I spend a lot more time with you than you know.
Well, that's the thing, though. When you like any one of our posts, we're immediately screenshotting and sending the notification off to the group chat. Like, yes, you like my post.
Now don't tell me that.
Yeah. I'm not afraid to
now
admit
I'm
it. We
start playing
fanboy
favorites.
a lot.
It's not the first time that it's not the first time that we've referenced our chat like a bunch of middle school girls, and it's definitely which I showed I sent you our response when you said yes. It was very accurate.
That was great.
GIF of our reaction. We'll have producer Paul throw that on the screen to show how enthusiastic we were that you were willing to join us, so people will know we weren't making it up. But
wow, and your timing is perfect because I'm in a hotel tonight anyway, so I might as well be having fun chatting with you guys. Then whatever else I'd be doing, which is probably work. So.
Well,
we're watching.
Speaking of work, do you want to say anything special about Shea Engineering Services, or give yourself a plug before we go.
Things are moving forward. I've been working a lot with a couple of other guys, Mike Savigny and Ray Lawrence. These guys. I've known Mike probably 25 years. He's a really good guy. I started working with Ray somewhere around 2016.
She from SeaTac? Is that?
Yeah, Mike owns SeaTac. And Ray has been a shop floor engineer, process engineer for 28 years. He and Mike went to school together at RIT in the 90s, and he turned in his ground strap to start working for Mike. So he does a lot of training. He's an IPC certified trainer. He's doing a lot of work with them. I can't tell you how much I like these guys. It's time for me to get off the road. I've been a road warrior for 25 years, about to turn 60. It beats the heck out of you. So I'm working a lot with Ray and Mike to carry all the momentum forward that I've built over the last few years. And I got to be honest, and a lot of processes, I got to say Ray's better than me. For 16 years, I've been going out, flying in on Monday, talking to people Monday afternoon, spending 3 days in the factory, assessing processes, giving them hints and tricks, finding out the gap analysis, doing training, recommending services, squeegee blade stencil manufacturers, tooling manufacturers, profiler manufacturers, and I thought I was pretty good at it. I can step back now because somebody is as good or better and they can carry it forward. So you're going to see a lot more cooperation or consortium action between Shea Engineering and SeaTac. And I'm really happy about it because I was probably on the route to retirement and I would leave nothing behind. Now I'm actually working on a really cool training project to help leave all my knowledge behind. And it's going to get me off the road, and Ray's going to be going out and assessing projects or processes. And he's got more tricks up his sleeve than I do because he's fresh off the floor. I'm on the floor a couple days a month. He's been on the floor every day for 28 years. So you're going to see a little bit of a shift in that direction because my back's killing me. I can't keep traveling. All my friends are retired, and they're like, "Oh, you want to go somewhere Wednesday night?" And I'm like, "No. I'm going to be in a hotel in the Midwest." So we're going to see a little bit of shift next year as I spend more time at home and take on a project of figuring out how to download 35 years process engineering into somehow web-based format that I can share with everybody. And
That's
Ray's
cool.
going to be going into customers. Yeah, it's going to be real cool. It's going to be really, really cool.
I'm actually, honestly, I'm just a little surprised that producer Paul didn't just like break into the podcast and just be like, I'm here, because that's like the stuff he loves to do.
So yeah, you're going to see a little bit different direction for Shea Engineering next year, and it's going to be pretty cool. And the industry has been so good to me for the last 35 years that before I leave, I want to give something back. And I want all the fun I've had and all the knowledge I spread to be carried on forward.
Have you shared these sentiments anywhere? Or are we going to be like breaking news here? Is this going to be like a press releases are going to start flying once people start watching this? Or
you got the scoop.
All right.
You heard it here first.
Yeah, you did. You did. I thought it would be, I've been talking about it for a while. We talked about it more at SMTAI, and Ray and I taught a class together, and it worked out great. You got the notes from that class. I've got a huge amount of confidence in him, and like I said, I've known Mike since we worked together at MPM in like year 2000. So
very cool.
I'm really happy about the cooperation of the consortium and that somebody's going to carry that torch forward and keep educating and developing and coming up with the next generation of processes. Because right now, I am, of all the people that grew up with SMT, I'm like kind of on the tail end of that curve. I'm the younger end of that curve. A lot of the process engineers that I grew up learning from are already retired. And there's this huge experience gap. So we have to figure out how to fill it. So that's kind of my my plan for, I don't want to say world
Yeah, 'cause
domination, but personal satisfaction.
well, eventually we're going to have to deal with 4 2s, right? Like
Yep.
we eventually. So somebody will have to figure it out.
Well, we started by cutting the leads off the through-hole parts and stuffing solder paste through a silk screen like you made T-shirts. And so we had big, bulky things. And for the last 35 years, we've made them smaller and smaller and smaller. We've switched to alloys. And we all grew up and learned with that. You throw somebody fresh out of school into that now, and it's overwhelming.
Mm.
If you think about all the different disciplines that go in a surface mount, you got to know your fluid mechanics. You got to know your motion control. You got to know your vision systems. You got to know your high-speed electromechanics. You got to know your optics. You got to know your thermodynamics. You got to know your physics of optics. You got to know your statistics. I already mentioned optics. You got to know your heat transfer. You got to know your chemistry. You got to know AI algorithms. You got to know logistics. You got to know a lot to be a line engineer. Mm. And when you first come out of school and nobody tells you how to apply those principles, you just get deluged and overwhelmed, and you go off to a simpler manufacturing process, over to the metal brakes or the injection molds or the back-end assembly. And so we see a lot of young people coming in, and within a couple of years, they're like, I'm tapping out. It's too overwhelming. So that's one of those sort of something I have a penchant for. We've got to have something. I'm looking right now at the next generation of leaders for this industry. You guys are going to be the board of directors of the SMTA or the PCEA. You're going to be the influencers. You're going to be the ones who push technology forward, especially in stencil technology. So we need to fill the experience gap. We need to be able to download all that, because you don't have 35 years to learn it. Your customers want it now. So that's what's in the future for Shea. It's going to be fun.
Awesome. Thank you very much. This was a fun Rev 1.16.
My pleasure.
And hopefully everyone joins us again for 1.17. It's going to be hard to top this. Thank you again. Till next time.
My pleasure. Thanks, guys. It's been my pleasure.